Okay, let's walk through another example using this method. In this reaction for the formation of ammonia, both nitrogen and hydrogen are involved. On the reactant side, I have 2 atoms of nitrogen. There's a subscript. And I have 2 atoms of hydrogen. On the product side, I only have 1 atom of nitrogen, but I have 3 atoms of hydrogen. So neither element is balanced. Let's start with nitrogen. To get 2 atoms of nitrogen on the product side, I need to multiply 1 by 2. So I'm going to put a 2 in front of where I see the nitrogen. That'll change nitrogen to 2, but now I've got 2 times 3, 2. So I have 6 hydrogen. So now hydrogen needs to be balanced. To get 6 on the reactant side, I need to multiply this number by 3. So I find hydrogen, put a 3 in front, and that will give me 6. So now I've got 2 and 2, 6 and 6. I am balanced. Let's try one that's a little bit more difficult. In this problem, we've got polyatomic ions. My suggestion to you is if you have a polyatomic ion that does not change from the reactant to the product side, keep it together. Don't separate it out. It'll make your life a little bit easier. So we're going to count the polyatomic ions as if it were one particular atom. Okay, so on the reactant side, I have 1 magnesium. I have that polyatomic inside parentheses and a 2 on the outside. So for that entire polyatomic, I have 2 of them. Aluminum, I have 2. Oxygen, I have 3. On the product side, I have 1 magnesium, 1 oxygen, 1 aluminum, but 3 nitrates. Okay, magnesium is balanced, but nitrate is not. Here I have 2 and 3, so I have to look at the first common product. First common product of 2 and 3 is going to be 6. So on the reactant side, I need to multiply 2 by 3 to get 6. So if I look up here, there's my nitrate, so I'm going to add a 3 in front, but it also changes magnesium. So I'm multiplying magnesium by 3. Oops, sorry. So I'll have 3 magnesium. So now magnesium is no longer balanced. I need to multiply this side by 3 to get 3 magnesium. So I put a 3 in front, but it also changes oxygen. Okay. Aluminum is not balanced. Whoops. So a nitrate on this side, I need to multiply by 2 to get 6. So I'm going to put a 2 in front of the nitrate, but that also changes aluminum to 2. So now let's double check. I've got 3 and 3, 6 and 6, 2 and 2, 3 and 3. So we are balanced. Let's try one more problem where I'm going to show you something a little bit different. So from this, the big takeaway is keep your polyatomics together. All right, combustion problems can be a little bit tricky because you've got oxygen split into both your carbon dioxide and water on the product side. So pay attention. I'm going to teach you some tricks that'll help make this a little bit easier. All right. Let's start by counting the number of atoms that we have on the reactant side. We have 2 carbon, 6 hydrogen, and 2 oxygen. On the reactant side, I have 1 carbon, 2 hydrogen. Now here's a trick I'm going to show you. Oxygen is split up, so I'm going to do some accounting above the equation. I have 2 oxygen there, 1 there, so I have a total of 3. Because it is split up, I'm going to leave oxygen for last. All right, but one thing that you should take note of is that number right there for oxygen needs to be an even number. So the number you put in front of water molecules needs to be an even number. Otherwise, you're not going to get an even number of oxygens. Right now, I would need to multiply this by 3, which means I would put a 3 in front of there, and that would change oxygen to 3. That's not going to work. Okay, so right away I know I need to change the coefficient on this side. So I'm going to erase this. Okay, my suggestion would be to go ahead and just go to the next highest coefficient number. So I'm multiplying that by 2, which means I'm multiplying this by 2. Gives me 4 carbon. I'm also multiplying the hydrogen by 2, which gives me 12 hydrogen. Okay, so now I'm going to get an even number on this side, because to get 12, I multiply this by 6. So that's an even number. Okay, if I multiply this by 6, now I have 8 oxygen, and I've got 12 hydrogen. Okay, to get 4 carbon on this side, I need to multiply this by 4. So now I have 4 carbon. 4 times 2 gives me 8, plus 6 gives me 14 oxygen. So now I can balance oxygen on the other side. I need to multiply 2 by 7. So I'm going to put a 7 in front of there, and that will give me 14. Okay, a little bit tricky. Save oxygen for last. Make sure that you have an even number in front of your water molecules. So start by trying to balance the hydrogen. If you don't get an even number, then increase that number by 1. I hope this helps.